Hey students, welcome to my YouTube channel KAMESH Studies. Here, I have Rishika Rana will explain the concepts of chemistry class 12th in an amazing way. So stay tuned with the channel and please like, share and subscribe for others also. Today, we are going to study chapter 1 solid state, and in this we are going to see the general characteristics of solid state and types of solid states and its difference. So have a look at it. Solid state we have learned in our earlier classes also, but yes, in 12th we are going to see solid state in a deep manner. So first we are going to see general characteristics of solid state. If you can see, the general characteristics are definite mass, volume and shape, right? We all know that mass, volume and shape can't be changed for solid. Next, if I'm moving to intermolecular, so intermolecular is divided into two. It is also my intermolecular distances as well as intermolecular forces also. So what are intermolecular forces? So intermolecular forces are those forces, right, which is having that much of property that it can attract or it can keep molecules closer. Next, if I am proceeding ahead, intermolecular distances are my short, and if I am moving to forces, they are going to be strong. Third, constituent particles. So what are constituent particles? The constituent particles which may be atom, it can be ion or it can be molecules also, right? So constituent particles, they are should have their fixed positions, right? If constituent particles isn't having their fixed position, right, so they are not going to be solid. Next, if proceeding ahead, it is incompressible and rigid, right? The last property of solid state is incompressible and rigid. Absolutely, right? If I'm taking any example of solid, I can't even compress it because it's a rigid object. Next, if proceeding ahead, types of solids and its difference. Types of solids and its difference. So we are having two types of solids. First is amorphous and the second is crystalline. So what are amorphous solids? So amorphous solids are those solids where we are having the regular pattern of arrangement of particles over a short range, right? My pattern is repeated only for a short range, right? My regular pattern is repeated only for a short range. Short range, you can see that it is only for short time. For crystalline, if you see, regular pattern of arrangement of particles over a long range order, which says that my pattern is repeated over a long period of time. So we are also having the examples. The examples are of amorphous are glass, rubber, plastics, etc. And if I am proceeding for crystalline, my examples are NaCl, quartz. Quartz is SiO2, right? Quartz is SiO2. And if I am proceeding ahead, we are going to see the most important thing, that is my isotropic and anisotropic. So isotropic, which means that it is having fixed properties in all direction, right? Then it says which properties. So fixed properties, mechanical strength, refractive index, electrical conductivity, etc. So these are the properties which is fixed in all direction, right? So if you are seeing for anisotropic, it is exactly the opposite of it. Anisotropic means different properties in all different directions, right? Next is which properties consist of anisotropic. The properties are electrical resistance. Mu is called as refractive index, right? The sign that you are able to see with the help of u, that is called as mu, which is called as refractive index. So yes, first let's have a look on the examples, on the pattern. I am giving you one example which you can understand amorphous and crystalline in an easiest manner. So yes, here if you see, you can see amorphous and crystalline. If you see in the figure of amorphous, it follows the regular pattern of A, B, A, B, A, B, if you see it, right? And if we are moving to crystalline, crystalline is not having the regular pattern, right? Amorphous is having regular pattern, but if you see for crystalline, it not shows my regular pattern. Next, let us have an example of anisotropic and isotropic with figure. So yes, if you can see, if I'm moving from A to B, right, either on, if I'm moving from my left hand or either I proceed to right hand side. So if you see from left hand side, you can see that blue circles, right? Blue circles are from A to B, 1 2 3 and 4. And if you are moving from right hand side, you are having red hollow circles, 4 hollow circles, 1 2 3 and 4. So if you see, even if you are moving from left, even if you are moving from right, from both sides, if you see, right, so you can observe that I am having same properties in different directions, means I can see same properties in all directions. So but and in the same, so this is going to be my isotropic. And if I'm moving from C to D, and if I'm moving from C to D and my lower side, so from my lower side, if I'm say it is starting from red, and if it goes to D, it is ending with red. So you can see that one red, one blue, one red, one blue, one red, one blue, and then it is going to proceed likewise. And if you are moving from C to D at the upper side, right, so you are going to have starting with red and it is ending with blue. So red, blue, red, blue, red, blue. So if you see in different direction, it is having different properties. So this is called as my anisotropic. Hope you are clear till this. So yes, if you have cleared all this, please like, share and subscribe for others also. Okay, and don't forget to press the notification bell in order to get the updates first. So yes, we are going to see the difference. That is my table 1.1, right? We are going to see the difference. That is my table 1.1, which is the most important for 3 marks as board perspective as well as for MCQ. Sometime it is asked also. So yes, if I am proceeding ahead, I am going to see that these two are the things that is given after table 1.1, right? We are going to see it, but let us have a look at this first. Okay, what are polycrystalline solids and my amorphous and silicon solids? So polycrystalline solids are those solids, right, which appears which says that which looks like amorphous, right, which appears as amorphous, but they are having your microcrystalline structures, right, small structures of crystal which is present in that, so that are called as polycrystalline solids. So next, if I am proceeding ahead, I am having my amorphous silicon. So what is amorphous silicon? Amorphous silicon, which is my best photovoltaic material. MTRL is material here, right, is best photovoltaic material. So best photovoltaic, I have written here between a space, so you can easily able to remember. Photo, that is light, and voltaic, that's a kind of a voltage. It's a trick to remember. Photovoltaic, right, which is used for converting sunlight to electricity. This must be asked in MCQ, right? This may be asked in MCQs. Okay, so let's proceed towards my difference between amorphous solids and crystalline solids. So yes, if you have cleared all this, so please write in the chat section, in the comment box, that we have crystal cleared it. Okay, and we are going to see the difference of it also, right? Difference of amorphous and crystalline solid is most important for 3 marks for board exams. So attend it very perfectly. So amorphous solids and crystalline solids. So amorphous solids, if you see amorphous solid, it is having irregular shape, as we have seen that pattern is not repeated for long range. So for amorphous, it is only going to be for short range. So my shape is going to be irregular. The same if I am moving for crystalline, it is having definite characteristics and geometrical shape. Okay, so it is having fixed shape, right? Next, if proceeding ahead, amorphous solid is having short range order, right, because pattern is not repeated for long time, so it is having short range. Next, for crystalline solid, it is having long range order because my pattern is repeated for so long time. Next, if I am proceeding, third is gradually soften over a range of temperature. Means if you are going to melt it, if you are having any kind of melting, so melting is going to be within some range. Let's example 278 to 372, right? And if you are moving for your crystalline, right, so it is having melt at sharp. Sharp is your exact, right? You are having your exact melting point. You are going to have your exact melting point. That is, let's say it can be 383, right? It can be 383. In order to understand this, I'm giving you very simple example that whenever you are going to giving your exams, and after when your exams are over and when you are going to calculate your score, right? You are going to calculate your marks at home. So what you are going to say that exactly, but I can have this much marks, right? I can have let's say if you are having 100 marks test, so what you are going to say, between 78 to 83 maybe I can have a marks, right? So that is going to be your personal experience exam marks, right? So but if you are moving for crystalline, right, crystalline is your result, right? Your result. So in your result, let's say that you are having your 82 marks, you are having your 82 marks from 100, so that is your exact. So your amorphous is your marks estimated by yourself, and crystalline that shows your result. So proceed to ahead. Hope you got this very clearly with the help of this example. Proceeding ahead, we are having when cut with a sharp edge tool, it's split into two irregular surfaces, right? So if you are moving for amorphous, so whenever you are cutting it, so it is going to split, it is going to divide into two irregular surfaces, right? Your surfaces which is divided into two, they are going to be irregular. But yes, if you are moving for crystalline, when you cut with sharp edge tool, it's split into two surfaces, and my generated surfaces are plain and smooth, right? It exactly. But if you are moving to crystalline and when you are cutting it with your edge tool, so it exactly splits into two pieces, and those two pieces must be plain and smooth. Proceeding ahead, they do not, for amorphous, they do not have a definite enthalpy of a fusion and characteristic, they have definite and characteristic enthalpy of a fusion. Hope you got this. Enthalpy, that is change in energy itself. Next is isotropic in nature and anisotropic in nature, that we have already seen that amorphous solids are isotropic in nature and crystalline solids are anisotropic in nature. Also called as pseudo or supercooled solids. My amorphous solids are also called as pseudo or supercooled solids, whereas my crystalline solids are called as true solids. The examples are quartz, glass, plastic, rubber, etc. Right? This consists the example for amorphous. So for crystalline, examples are NaCl, quartz are examples. So remember, students are mistaking in this itself that for amorphous, the quartz, glass is the whole word, right? Is a whole one example. And if you are moving to crystalline, that is only quartz only. Okay. So don't be confused within quartz, glass and quartz. So yes, I hope that you have understood the concept well. We have discussed in this classification of solid state and introduction of solid state. Yes, if you have understood the concept well, please write in the chat section crystal clear. If you are new to the channel, please subscribe it and don't forget to press the notification bell in order to get the update first. See you soon in next video. Have a great day, dear.